In this video we're going to figure out what the derivative is of inverse sine of x. So let's start by rewriting our expression as y is equal to inverse sine of x. Now let's apply sine to both sides of the equation. So we're going to have sine of y, sine of inverse sine of x. Now the sine here and the inverse sine here just cancel, so we're left with sine y equals x. At this point we want to differentiate both sides of our equation with respect to x, so let's go ahead and just write that up here. Notice here we have a function in terms of y and we want to differentiate with respect to x, so we're going to have to implicitly differentiate the left hand side. So we're going to have cosine of y multiplied by dy over dx, and the derivative of x with respect to x is just 1. Let's divide both sides of this equation now by cosine of y. So these two cancel, so we just have dy over dx is equal to 1 over cosine of y. Now at this point we're going to want to make use of the following trig identity. I'll just write it over here. Cosine squared of x plus sine squared of x equal to 1. So let's just start by rewriting this in terms of y. Now we want to make cosine of y the subject of this equation, so let's solve for cosine of y. We're going to start by subtracting sine squared of y from both sides of the equation. And we now have cosine squared of y is equal to 1 minus sine squared of y. Now let's take the square root of both sides. So we have cosine of y is equal to the square root of 1 minus sine squared of y. Now we can substitute this into our equation up here. So let's go ahead and do so. We have dy over dx is equal to 1 over the square root of 1 minus sine squared of y. Now remember before we wrote sine of y is equal to x. So let's go ahead and just square both sides of this equation. Now we can substitute this value for sine squared of y into our equation up here. So we have dy over dx equal to 1 over the square root of 1 minus x squared. And that's the answer to our problem.